last topic in chapter 3 are exponents, and I kind of already talked about those a little bit. I said that exponents are repeated multiplication, and that is still true. So if we have to multiply something over and over and over again, then we have an exponent. We've seen this a little bit when we were looking at the sequences back in an earlier section. But if I have to keep doubling things or tripling things over and over and over again, that's when I get these exponents. Now there are some rules with exponents, so this is just a little bit of an algebra review. I'm going to kind of zoom it in because exponents are a little bit hard to see. The a is called the base. So when I'm multiplying the base, I don't do the same thing to the exponent. I'm going to add the exponent. I'll write that out to the side, and I'll write the answer up as well. So we would add m plus n. So if the bases are supposed to be multiplied, a times a, we see that times right there. What we really do is add the exponents. Notice that a stayed the same. My base stayed the same. I didn't change it. For this next one, this is actually supposed to be an exponent raised to an exponent. So whenever my base is being raised to a power, what I do is I multiply the exponents. So what you see isn't what we're going to do. So that makes it a little bit challenging. And for this last one, whenever I'm supposed to be dividing those, and notice again, we've got that same base, a divided by a, it kind of makes sense since when I was multiplying, I added. What goes with division is subtraction. So I'm going to subtract the exponents. So let's see these put to use down here. I actually am going to go ahead and maybe have you hit pause and try A and C. I'll work B out in just a second. But go ahead and hit pause and see if you can get these rules up here to apply to those problems down below. All right, let's see how you did. For this first one, I'm going to add the exponents. I'm going to show my work. You don't have to show your work. And the direction said to leave in terms of exponents, so I'm not going to type 6 to the 9th in. I'm just going to leave it as 6 to the 9th. And for C, this is where I would multiply my exponents. So I'd get 5 to the 12th. Now B, I told you I would do. This one's a little bit more challenging. I can't apply my rules unless I have the same bases. If you look up here at the top, I always had the same base when I was doing these rules. My base was A. So I've got to get these guys to have the same base. And I remember that 6 is 2 times 3. So I could write 6 as 2 times 3. And then it had a 5 in the exponent. So I'm going to carry that 5 down. So my new problem is really the exact same problem, just written differently. So I did have 6 to the 5th, and instead of 6 to the 5th, I wrote it as 2 to the 5th times 3 to the 5th. Because 2 times 3 is 6, and then that exponent's going to carry down. Now, I think I can look for those same bases, the common bases. So I've got a 2 to the 5th and a 2 cubed. Again, I'm going to show my work. You wouldn't have to. You could get an answer. 3's have the same bases. Oh, pencil stop working again. Gonna come up here and get it going. So I'm adding those exponents. So my final answer would be 2 to the 8th times 3 to the 7th. And I would leave it just like that. I'm not going to multiply the 2 times 3. I'm not going to add those exponents together because the rules only work if we have the same base.